is Miss Liz's computer. Okay, we're recording. All right, so I wanted you guys to fill in the blank for this exponential function. I know it's a growth function because when I'm reading from left to right, or if I'm looking in the positive direction, my graph is going up, right? So this is a positive function. So this is growth. Next, I ask myself what my floor is. My floor is at -1. So k is going to be -1. I can't see it. All right. Next, I've got my h. My h, that reference axis is over 2. So I'm going to say h is 2. K is -1. It's not going to be +2 because we're going in the positive direction. So this, if I set it equal to 0, is 2. Remember that? Yeah. Okay. All right. So from here, I'm looking at how much of a stretch do I have. Normally, if it was just a scale factor of 1, it would just be 0, 1. I'd only have to go up 1. But since I'm stretching up twice as much, I've got a scale factor of 2. All right, you ready for the magic? Next, I would go over 1 and up a certain amount, right? I have to go up 1, 2, 3, 4, 5, 6. How do you get from 2 to 6? Okay. I will do it one more time. Okay. So actually, you can look at it like this. Isn't there, to get from here to here, isn't it 2, 3 times?
True.
Right? Don't I have to do 2, 3 times? So I have a factor of 2. I do it 3 times to get there. Okay, there's an algebraic way of doing this. I'm going to show you how to do it right now. You ready? I did. I counted it. It's 6. And to get there, I would need 2 times 3 is 6. Everybody wants to divide. I don't know why you guys want to divide. It's the same thing, but okay. So check this out. I could have figured this out right from here. Let's see. Miss Liz doesn't use that. I'm using her computer. Okay. So I have 2 points on my graph. I have 1 point at 2. Sorry, we're here. 2, 1. That's 1 point on my graph. I have another point on my graph that's over 1, 2, 3, and up 1, 2, 3, 4, 5. 3, 5. Right? Okay. Watch what happens. Let's pretend that I don't know what my B is. It's just plain old B. I don't know my base. I do know a couple of things in here. If I'm at 2, 1, that's on my graph, right? That's part of my graph. So 2, 1, 1 represents my y value, right? So here's my y value. And 2 represents my x value. So this would be a 1. And this would be my x value. But do you see what happens when I say 2 minus 2? That becomes 0. Am I ever going to find out what b is if it's b to the 0? Because that'll always make it 1. So the first reference point is not going to give me that. But check out what happens when I use the second reference point. When I use the second reference point, which is at 3, 5, 3, 5. Now I'm going to substitute in for real. So my y value is 5 equals my 2b to the x. X is 3. So 3. I should have made it blue. 3 minus 2. I'm not going to do all of them this pretty. Plus 1. Minus 1. Sorry. Okay, check out what happens when I do this. I get 5 equals 2. 3 minus 2 is 1, right? So isn't that just b? And when you go to that second reference point, it's always going to be that way. Okay? Because you're going 1 over, so it's always going to make an exponent of 1 minus 1. Now what do I do? Add 1 to both sides, and I get 6 equals 2b. Divide by 2, and I get b equals 3. So you could do it algebraically, or you can think like the graph, right? And think about the transformation that's really occurring. Okay, this is how teachers would normally teach it right here. All right? After doing a meeting with the teachers yesterday, I said, you know what? I really wish I could figure out the structure in just the, I know it's there, I know there's structure there. And then the teacher that I was working with, she's like, I just figured it out. So actually it's Misato. Misato was looking at this length compared to this length, and we started looking at a couple of them, and we realized there was structure there. All right? So pretty cool. You guys want to try another one? It's going to be like that for all of them. So let's try another one. You guys try this. I'm going to pause it. 2, 1. Okay. All right, so my floor is at -4. K is -4. H is, we're shifting over, 1, 2, 3. So H is -3. So this is going to be +3. My scale factor is up 1, 2, 3. A is 3. So my base must be, there's up 3. There's up 3 again. There's up 3 again. So how many 3s do I have? We're here. 1, 2, 3. From the floor to the first reference point. Okay? Another one? Okay. Oh, I got a ton. I've got like 5. You don't need to know how to do it algebraically. No, we're going to do it for a few, like 10 more minutes. Okay, you guys try this one.
It's a decay, not a growth.
Okay, so let's get all the pieces together. Perfect. Okay, so what's my floor? -2. My K is -2. My H is 1, so that makes this x minus 1. Your scale factor is from here to here, 1, 2, 3, 4. We have a scale factor of 4. Then most of you said, I've got a scale factor of 4 2 times. Okay. So, Philip, since it's a decay, what do you think we need to put in there? Here? Here? Here?
I feel like we're wrong.
No. Okay. I'm going to throw you through a loop for a second here, okay? I'm going to make you think. It might hurt a little bit. Okay? All right. Let's use that .06. to find our b. Okay? So let's find it. I'm going to do it pretty quickly. So my 0.06, my y is 6, equals 4b to the x. What's my x? 0. 0 minus 1 minus 2. What happened that's different from the last one?
You have a 0.
It's not to the 1, it's to the negative 1. That changes things. I'm going to add 2 to both sides. I get 8 equals 4b to the negative 1. Divide both sides by 4, and I get 2 equals b to the negative 1. Can you make sense of that without me doing the algebra? No. It should be it's 1 over 2. Good job, Michelet. Hey, you guys know when you have negative x equals 2, then x equals negative 2? Well, when b to the negative 1 equals 2, then b equals 1/2. I'm going to do the algebra for us because I don't want to skip over this. But it has to be to the negative 1. It wouldn't work if this was negative 3. That wouldn't work because then it would be the cubed root. So it only works with the 1s. So let me show you the algebra that's involved here. So if I didn't want to go straight there, I need everybody to be quiet for a second, okay? If I did straight algebra, this would be 2 equals 1 over b. Wouldn't that make it a positive exponent? Then if I multiply both sides by b, I get 2b equals 1. So b equals 1/2. All right. Or you could just ask yourself, you all were correct? You all were correct when you guys thought it was 2. Because the graph was making it look like 2. But this is a decay graph, and decay graphs are always between 0 and 1. So it should have just been 1/2.
So if it's negative 1, you basically just...
What would negative do to my graph?
It would make it go back.
It would reflect across what, Sarah? The x-axis. A negative graph would make it look like this. That would be negative.
So how would you do it?
We're going to do it. Don't you think it's coming?
Well, I don't know.
Right? I am recording. Okay. Yeah, you're in the video now.
Was my name said? Hi, Mom.
Okay. Think about this one for a second. You guys do this one. All right, you guys, I'll draw the lines and the points for you again. So your floor is here. Your reference axis is here. This point here is at 0, -5. And this point here is at 1, 1, -1, 1. There's your point. I'll give you guys a second. All righty. So my floor is up at 3. So I'm going to say K is 3. My H, my shift horizontally is back 1, -1. So that makes this +1. My scale factor is, if I'm here and I have to go not up 1, but down 2, this is a -2. Is that what you thought? Good. So now I just have to figure out how much it takes to get from here. So this is 2, 2, 2, 2. So how many 2's do I have? 4. Now, is it 4 or is it 1, 4?
1, 4. You have a 1.
4.
Oh, because it's +1.
No, that's not why. Why? Hold on, hold on, hold on. Angie, Angie, explain. reflection would make it growth, not decay. So this is a negative growth. Actually, we're not going to call it negative growth. It's growth reflected over the x-axis. You should in your mind be reflecting it so that you can figure it out. You guys are so excited. That makes me so excited. What? Yes. Okay. I'm going to erase this. No, if it was up like this, it would still be 4, but you would not have a negative sign in front of the 2. Does that make sense? So this would, okay, so this is a good question. Michelle has a good question. She wants to know when it would be 1 over 4. Well, it would be positive to 1 over 4 if it looked like that, right? And then if I were to reflect that, that would be 1/4 with a negative in front of the 2.
Okay, I understand now.
Yeah? Top right is 1/4. This one's 1/4 base. This is 1/4 base with a negative in front. This is a 4 base. This is a 4 base with a negative out here.
So lefts are always whole numbers and rights are always fractions.
Yep.
And then below is always with a negative and above is always
Good. You're making structure. I love it. Okay, let's erase all that. Wait. What? Okay. You know what I could do? Okay, so we'll put 1/4. This one is 4. This one is negative 4, but you have to be careful because the negative has to be on the outside, right? I'm going to duplicate this slide so you guys have it. Wait, Miss Liz doesn't have duplicate on here. Here it is. And then I'm going to go back, and I'm going to erase it. Yeah, it'll be on school. What did I miss? What did I take off? The 4? And this one is -2? Okay, you guys ready for another one? You want to challenge one? Come on, let's challenge ourselves. About that one. You guys can do it. I'm going to pause it. Are we recording? Perfect. Okay. All right, guys. So, you know your your K. What's your K? -1. You know your H. What's your H? 2. Over 2, so just like this. What's your A? You guys all got that. It's a half. All right. Now, I heard a lot of it. So if this is a half, why am I talking over everybody? So if this is a half, there's a half, another half, another half, another half. How many halves do I have? I have 10, but you guys almost had it. Why 1 over 10? It's decay. Good job. It's dropping. Philip, look. Okay, listen, guys. Hold on. You're right. Listen up. If it was like this, it would be 10. But it's decay. Remember, what happens when you have decay? It becomes a fraction, right? The reason is because of this, to the negative exponent. Okay, you guys are mixing up. You guys are talking over me, first of all. Okay, I know you're excited. You guys are mixing up the fact that there's fractions and the base is a fraction. What does it mean when the base is a fraction? It just means it's falling instead of growing. It's growing at the exact same rate. It's going in the other direction. Okay. All right, we have to move on, guys. We only have 20 minutes, and we haven't even started the lesson. Okay? All right. Well, that's part of it. Okay, so there's homework. Guys, I'm not going to talk over you anymore. That's 1 minute after school. I'm tired of saying it, and it's on recording. So I'm really getting tired of saying it. Okay, so the first part of your homework is you have to be able to give me a function based on a graph, which you guys can do well. This is the hardest one, and there's not one that's that hard on your homework or on your quiz. All right, the second part is being able to describe what's going on here. So let me do the first one for you. So this one is a decay. First of all, it doesn't have a horizontal shift. There's nothing here. It does have a vertical shift up 2, right? So my floor is up 2. Normally, I would go up to 0, 1. Is there any scale factor that would make me go any higher? No. Right? My next point, if this was 3, would be what? Over 1. If that was to the 1, what would it be, guys? Over 1. Up 3. But Sarah, this is a fractional, so it's left 1, up 3. It's decaying. Okay, hold on a second, and I'm going to tell you exactly why. All right? Because this is a fraction, so if it was like this, if I put 1 in, I would get positive 3, and if I would put negative 1 in, I would get 1/3, right? So when I do that with this one up here, and I make 1/3 to the positive 1, when I go over 1, I get 1/3, right? But when I go to the negative 1, what happens to my graph? What's 1/3 to the negative 1? So when I go over 1, so they're both the same, but the exponents make them, it reflect over the y-axis. So when you ever see fractions like this, just think, well, it's the same thing as this one, right? Only it's on the other side of the y-axis. So the fraction actually doesn't make it small. The fraction changes the direction. The fraction makes it fall instead of rise. Okay, let's try another one. All right, so I would say, now I don't have graphs on your homework, I just want you to describe it. So on your homework, you would say that this is a graph that's decaying, right? And it's shifted up twice. So on this one, I would say this is a graph. It's also decaying, right? Because it's fraction. So it's decay. It's shifted down 2 and to the left 3. Sorry, to the right, to the right. To the right 3, thank you. To the right 3. All right, so let's do that. Let's graph it. Now, you don't have to graph it on your homework, but we're going in reverse now. We've been going backwards, now we're going forwards. So this is down 2. It is to the right 2. to the right 3. 1, 2, 3. What happened there? There we go. To the right 3. From this point right here. Normally I would go 0, 1. Am I still going to go 0, 1? I don't have any scale factor. There's a scale factor of 1 here. So I'm going to go 0, 1. Now normally I would go over 1, up 5. 1, 2, 3, 4, 5. But instead I'm going to go to the left 1 and up 5. It's going to fall instead of growing. Why up 5? Because if I had 5, to the 0 made 1, right? 0, 1. That's where that's coming from. But when I put a 1 in, when I shift over 1, doesn't this shift me? Right? When I shift over 1, that gives me 5. So when I shift over 1, I would normally go up 5. But since it's going in the other direction, that's what made it like this, guys. Right? So you go over 1 this way and up 5. You guys try the last one. See if you can make sense out of it. It'll be the same thing, right? Only what? What's the negative do for me? Nope. It makes it not upside down, but let's be more technical. Reflected over what? Over the x-axis. So this is reflected over the x-axis. It's decay still. And it's shifted to the left by 1. So shifted left 1. Is it a plus sign? Yeah, so that means it shifted to the left. Is it shifted up or down? No. That asymptote is y equals 0. And then normally I would go 0, 1, right? But in this case, I'm going to go 0, negative 1. Next, I would go over 1, down 5. But instead, I'm going to go to the left 1 and down 5. 1, 2, 3, 4, 5. So this looks like this. Okay, so again, on your homework, you don't have to do the graphs. You just have to describe what's happening with that. Okay? All right, let's move on. All right, so now I want to talk about your homework last night. Dylan, can you pass back their homework? Okay. No, I wanted you to go as far as this right here. Well, first let's make sense of it. All right, so it says Sue has a lamp from her great-grandmother. She's appraised it and found out it's worth $1,000. So this part is how much it's worth, right? The initial amount is worth $1,000. That means on my graph, guys, it's going to be up at $1,000. Right? Not funny. Right? It's going to be up at $1,000. At no time, right, the day today that I got the lamp appraised, it's worth $1,000. So that's 0, 1,000 on my graph. Then it says, what does this tell me, this number right here? It's increasing at 8%. So this part right here tells me that there's an increase or a rate of 8%. So what it was asking me for was, change my color, let's do purple. What it's asking me is, how long will it take before it's worth $2,000? I want to know where the graph's going to be at $2,000, up 2,000 more. I know it's going to do something like this. I just don't know when it's going to end up at the 2,000 mark. So we need to go on Desmos and find out. All right, so part of your homework, you were supposed to just do this. I was hoping you were going to be able to find out exactly how much time. So t would be 9 years. But what we're going to do is we're going to take this information. This is what you should be able to do. So you have a 2000. I want to know where it's at 2000. So let's go to Desmos and check that out. So this is Miss Wiz's computer. No. All right, guys. So it was y equals, what did we start, 1,000? And then my rate was 1.08. 1.08 to the t. I should have like a, here it is. So to the t, I just use this button here. Take it to the t. All right, I can't see it. So it must be big. Why am I zooming in? I know it's big, guys, because look, it's supposed to be up at 1,000, right? It's going to start at 1,000. Well, if it's going to start at 1,000, why am I messing with these little numbers? Right? So if I go into settings, wouldn't I say my y-axis just has to start at 0? Like, I'm not going to go less than $0. And how high am I going to go on dollars? 2,000. So let's put in 2005. Let's see what happens. All right. So there's my 2,000. That's a little bit better, right? I can see 2,000. Now, if I really wanted to make it so I could see this really good, let's see here. I can't decide whether I want to show you this first or last. Okay. I don't want to know where it's at 1,000. See how it's crossing there at 1? I want to know where it's at 2,000. Here's a neat trick. If I write a constant light at 2,000, it shows me where the intersection is, right? Doesn't that make sense? It's kind of like I want to see where it's at 2,000, so I'm just going to draw a line at 2,000 and see where it crosses that graph. Okay, so since this is probably what, going in, I don't even know, but 500 is way too big, obviously. So what do you guys think? What years should we put? On the x-axis, it's not going to be any smaller than 0 years. How big do you think it's going to go? I would, 10 would be a good guess. Even if you couldn't even guess that, let's just talk 20 years. Let's even just talk 100 years. Who cares if it's going to be over 100 years because she's not even going to be here anymore, right? Seriously. It wouldn't make sense. Okay, so look at, now can I see it? I can see that intersection pretty well. All I have to do is go right at that intersection, and it'll tell me that after $2,000, after 8.7 years, right? So let's go in tenths. So I would say about 9 years or 8.7 years. Okay? Let's try another one. What do you guys think? Not so hard, right? So on your quiz tomorrow, you should be able to interpret a graph. You're not going to have to graph it on Desmos, but you should be able to interpret it. Okay, so here's one. So this one says the population of a small town is 15,000. So on Desmos, it's going to cross the y-axis at 15,000. That's where it's going to start going positive, right? Then what's my percentage? Let's see, A. So my starting amount is 15,000. My rate, can you guys tell me my rate just by looking at this? 5%. And how far do we want to get? Let's see, we're trying to get population, so these are going to be people. So this is 15,000 people. How many people do I want to get to? I want to get to 25,000 people. So what's my constant line going to say? It's going to say 25,000, right? So let's try it. So you guys remember the rate in the start? All right, so what was my start? 15,000. What was my rate? How should I adjust this? 5, because it's 5%. And I want to get to how many? 25,000. All right, let's see if you guys can scale this one on your own. What should I scale it as? On the y-axis, what would be my lowest point? 0. What would be my highest point? 25,000. Oh, look, I can see it right there. Do I even need to do any more? So where is it going to hit? Where's my graph going to hit? Oh, look, of course we can't see it, right? Hey, if it were rabbits, let's look. Population of small town, the population is growing by 5% per year, so we're talking years. So it would take 10.5 years, 10.5 years. All right, I think I should give you your homework. So that was growth. Tonight is decay. It's the same thing, only what? Okay, guys, this is what I'm going to ask you really quick. If this problem was decay, I need everybody to stop shuffling papers and look up here. If I was talking about population decline, how would this look different? Let me just duplicate this page and say it's decline now. Uh-oh. What happened? Okay. That freaks me out. Okay. All right. So this is now not growing, but declining. What would change? This would be the same. If it would be declining, what's happening to this? You would subtract it. So instead of being, so it would be this. We'll do G of T for, well, the D for declining. D of T. So if it was declining, it would be 15,000. And then I say 1 minus 0.05 to the T. So then this would be 15,000 to the 0.95. Do you see how that's declining, getting smaller? Okay. And then the problem obviously wouldn't make sense if it was 25,000 because it could never get to 25,000 if it was declining. So we'd make up our own number, like how long would it take before it'd get to 1,000 people? That's kind of sad. Let's not even talk about that. Population declining. It is. Okay, I'm going to give you your homework. You guys did a great job today.